Model 11 Part 2 notes. This is page 6. So both of these examples have got video Excel examples that you will want to watch. What I am focusing on here is the notation. All of the numbers are coming out of those recordings. Okay, so example 9, accordion, and I don't know why 9 is smaller than 10, so hopefully there are no issues reading that. According to the Pew Research Center, 13% of Americans do not use the internet. Suppose 15 adults are selected at random and asked if they use the internet. A, we want the probability that exactly 3 adults don't use the internet. So first off, my probability here is 0.13. My number of trials is 15. The probability that exactly 3 do not use the internet, which feels counterintuitive to say it that way, but that's okay, is going to be binom.dist 3, 15, 0.13, 0, which is walked through in that video, and we get a 0.1880. B, find the probability that at least 5 adults do not use the internet. So that's going to be the probability that x equals 5 plus the probability that x equals 6. And you will see in Excel how much easier it is to do, to add all these separately like I did on the last page. But when I do that, the probability that x is greater than or equal to 5, at least 5, ends up being 0.0362. Find the probability that fewer than 4 adults don't use the internet. Fewer than 4. That's 0, 1, 2, 3. So I want the probability that x is strictly less than 4, and I get 0.8796. Find the probability that between 2 and 5 adults inclusive don't use the internet. So this inclusive means include 2 and 5. So I've got the probability that 2 is less than or equal to x is less than or equal to 5. And I get 0.5902. And there's example 9. Example 10. We looked at finding the mean and standard deviation for this scenario earlier. Now we're going to use this to find probabilities. So here, my probability of success is 0.6. The number of trials is 10. These are my 10 healthy plants. So you can see how I set this up in Excel. I've created the entire table in Excel, which I'm going to go ahead and pull over here right now. 0106. Keep in mind all of our probabilities should be less than 1. Also, you can see at the bottom of the column in the Excel spreadsheet where I summed them to make sure I had not screwed something up or left something out. If I accidentally left out the 6, or if I typed in something correctly, it is going to let me know. Oops, I am off by 1. 4. See, I can't always talk and write at the same time. It's all good. 4 is 0.1115. 5 is 0.2007. 6 is 0.2508. 7, 2150. 8, 1209. 9, 0403. and 10, 0, 0, 6, 0. Now notice something. Our expected value was 6. You notice here that 6 is the highest, has the highest probability. That makes sense. Goes up from 0 to 6, and then it starts going down. Okay, so let's answer our questions here. The probability, that x equals 4, that 4 healthy plants grow, is 0.1115. C, the probability that 3 plants don't grow is going to be the same as the probability that 7 healthy plants do grow, which is 0.2150. D, the probability that at most 7 healthy plants grow, and I am going to go ahead and highlight this one. At most 7 healthy plants is everything from 1 down to 7. So that's going to be the probability that our success is less than or equal to 7. And Excel is nice. That'll sum all that for me, 0.8327. I can even slide that column in so that it rounds correctly. Okay, you will definitely need to understand this because you will definitely need to use Excel on exam 2. E, the probability that at least 5 healthy plants grow. So the probability that x is greater than or equal to 5 is 0.8338. And the probability that between 2 and 8 healthy plants grow, notice it doesn't say anything about this being inclusive. So this is 3 through 7. I get a 0.8204. We don't use binomial distributions a ton. You do need to understand this. It will definitely be on exam 2 and the final.